Okay, let's start doing homework 7, problem 1. In this problem, you're given a set of experimental data corresponding to the vapor-liquid equilibrium data for THF IPA, which are two chemicals. And basically, as you see here, you have your temperature, which is decreasing from 355 down to 388. And you have measured data for X, which is the gas phase mole fraction, or the liquid phase mole fraction in this case, because it's increasing steady increments, and Y, which is the gas phase mole fraction. So part A, you're asked, on the same figure, plot T versus X and T versus Y. Label your axes, use the O symbol to represent the T versus X data, and the star symbol to represent the T versus Y data. Okay, let's go ahead and do this. So the first thing you want to do is let me load MATLAB here. Okay, so you have MATLAB, and first thing you want to do is enter this experimental data into 3 arrays. So I have 3 arrays. The first one is T, and I put in my numbers, X, numbers, Y, numbers, okay? And I'm gonna suppress them with a semicolon so that they don't show up here. I already have them up there. I'm gonna do this in a new script, and I recommend you do the same. So just if you don't have the script window open, just go new script and create a new script. Just be careful, this script might open in a new window, a pop-up window. It's fine. If you want to dock it onto your main screen, just find this downward pointing arrow, right click on it and dock it, and it's gonna show up into your main MATLAB screen. Okay, so after entering your 3 arrays for the experimental data, let's go ahead and start plotting. So first thing is I need to plot T versus X. And always when plotting, your independent variable goes first because it will be shown on the x-axis. In this case, the independent variable is the temperature. And by independent variable, I mean the variable which you are changing. So if you're running an experiment, you'll have control over the temperature, and then you're changing, and then so you're changing the temperature and you're measuring the 2 other variables, right? So your independent variable in this case is the temperature. You have to see it on the x-axis, and then your measured variables will go on the y-axis. So for the first one, T goes first, and then X. So the X, which is the mole fraction, will be shown on the y-axis. And then I'm gonna use the O symbol to plot it, and I'm gonna add the letter B just to show it in blue. Okay, so this is my first plot command. Let me go ahead and run this. So again, when you run this for the first time, you'll be asked to save the script. Make sure you save it in a location which is easy for you to find. So for example, your desktop or your documents or a folder you create. Don't save the folder in the same location where MATLAB is installed, because you might end up overwriting one of the MATLAB functions, and this will create some errors later on. So make sure you save it with a name that's easy to remember. Don't use a general word like plot or something like that, because this will not work. In my case, I'm using homework 7 number 1, so try to have a naming sort of logic for your files. Anyways, so save it, run it. It might ask you to add to path, whatever. It's fine. Add it, and as you can see in the bottom right hand side here, I have my plot. So now I'm going to plot the second set of data. Before doing so, I'm going to write the command hold on. And what this command does is it just plots my second set of data on the same figure without basically removing the previous information on it. So I'm going to write plot, in this case T, comma Y, comma, and in this case I'm just going to use a star, and I'm going to add the letter R, just show it in red. Okay, So let's see. Oh, I have to run it. Okay, so let me run it. Here we go. So I see my second set of data here. So now I'm gonna do some cosmetics. So first thing I'm not happy with is that, it doesn't, ideally you don't want to have a lot of white space on your figure. And here I have a lot of white space between 335 and 340. So let me change this. So if I look at my T data, it goes from 338 all the way to 355. So let me use the function xlim, and basically I'm limiting my x-axis between 338 and 356. Let's try this. Let's run it and see the effect. Okay, so now the data is better fitting into my figure. Another thing I don't like is, it's not starting at a value, just there's no initial value and there is no end value, somewhere sort of in between. So in order to fix this, you can use another command. You can call it xticks, for example, which it is xticks, and you're gonna put your tick points. So I want it to actually start from 338. I want it to have increments of 2, and then I want it to end at 356. So let me run this and see. So here we go. So now you can see that starts at 338, ends at 356. Looks organized. So can move on. Let me do the same for yticks. So yticks, this 0.2 is, it's too big of a space. I'm gonna make it 0.1. So it's up to you to show your figure whichever way you want. Um, just show it in a way which you believe is easy to present. Okay, so I have my x-ticks, my y-ticks. So now I'm gonna show a grid. So I'm gonna write grid and run it. So I see my grid on this figure. And I'm gonna add a title for this figure. So I'll have title, vapor, liquid, equilibrium, data. Just a general title. I'm gonna add my X label. My X label will be temperature, Kelvin, and my Y label is gonna be, let's see, I'm gonna say X data in blue, Y data in red. Okay, just general labels. Here we go. So I have my X label and my Y label on this figure. Okay, so I think this satisfies part A. Um, let's move on to part B and see what it wants. So part B here, use the polyfit function, determine the coefficients for a third order polynomial for both t versus x and t versus y. Okay, so I just need to get the coefficients using the polyfit function. Okay, let's go back to the MATLAB screen. Let's write the commands for this. So all of this, let me add a comment here. So I'll add just a comment in my script. Part A, just to label it, and then I'm gonna add part B. So part B, polyfit. So let me create an array. Let me call it x data coefficients. Or let's just use coef because it's easier. Coefficients, you might end up with spelling errors if you type it too many times. Let's go x data coef polyfit t comma x, and I want it to be third order polynomial. So I'm gonna put in 2. So let's run it and see. This makes sense. Yeah, so I get my coefficients for a third order polynomial or a cubic polynomial for the x data. Let's do the same for the y data. Y data coefficients, and then I'm gonna use again polyfit t comma y comma 2, and let's run it. And I have my coefficients for the t versus y data. Okay, let me save this file and let's go back. So this satisfies part 2. Let's go back to the prompt and see what's required for part 3. Okay, for part 3, plot both the row and fitted data for both t versus x and t versus y on the same figures. Use symbols to represent the row data and straight lines to represent the fitted data. Okay, so basically I have my equations. I just need to show them on the same plot here on the bottom right. Let me add a comment. Part C. So in order to do so, I need to use these coefficients which I generated to plot basically the equation having these coefficients. So first step, I'm going to evaluate these coefficients over this range of temperatures. So I'm going to create an array. I'm going to call it tfit. And this array will basically have the numbers from 338 to 356 with increments of 2. And this will be the points at which I'm going to evaluate my polynomials. Alternatively, you can just evaluate them at the temperatures at which you measured your experiment, but this is another way to do it as well. So t underscore fit, and then I'm going to generate x underscore fit using the polyval function. So I'm going to have polyval, and I'm going to use the x data coefficients, which are the coefficients for a cubic polynomial, and I want to evaluate them over the range of t underscore fit. And I'll do the same for y, so I'll write y underscore fit is equal to polyval y underscore data underscore coefficients, and then I'm going to evaluate them at t underscore fit. Okay, so I have my lines. Let me plot them. So I'm going to just say hold on so that I don't erase the current lines or the current data shown on the bottom right. And I'll just say plot. Let's see. I need tfit because it's my independent variable, comma x underscore fit. And let's have it the same color as the x, which I think is blue. So let's just write b so that we have it as a blue line. And then I'll do the same for the red line, plot t underscore fit, comma y underscore fit, and then I'll have this as a red line. So let's run this, see if we have any errors, try to troubleshoot it, all of this stuff. Okay, here we go. So this should be your final plot here. So I have my experimental points and I have my fitted lines which go through these points. And I think this is, yeah, so this satisfies parts A to C in problem 1.